So today we're here at Gloucestershire Airport to film the last part of our documentary series all about securing the future of technologies. So we've already unpacked fintech, space, agriculture and creativity, and today we'll be diving into all things digital twins. So I'm going to be meeting Jess, which will head on over to talk more about the topic. Hello Jess, how are you?
Good, nice to meet you, Daisy.
Nice to meet you. So we're obviously here today to talk all about digital twins, but before we get started, could you tell me a bit more about yourself and your role at CACI?
Yeah, sure. I work as head of product for Mood. Mood is a platform owned by CACI Limited. CACI is a global company. We work primarily in tech and data, but today we're going to talk all about digital twins, which is one thing that we do for our customers. So we've come to Gloucestershire Airport today as it's actually a really good example of how a digital twin can be applied to a whole ecosystem. And we've actually worked with the MOD at refueling stations and modelling out that whole ecosystem, and also with airlines as well.
So what are digital twins? Can we talk a bit more about, obviously they're used in planes and refueling, but what is a digital twin?
So it's a virtual representation of something real. So it could be of an asset or a whole operation or even an entire organisation. Initially, they were used to design and monitor physical assets such as manufacturing machinery, and even airplanes were designed using digital twins, and they continue to be. But more recently, they've evolved into encompassing whole organisations and whole operations and ecosystems. And it allows you to model out all of the different moving parts and entities such as people, processes, data, strategic goals and even external factors such as competitors, suppliers and government policies, and how all of those things interrelate. And it allows you to kind of navigate complexity a lot more easily, seeing the bigger picture and being able to drill down right into the granular detail. That allows you then to kind of focus in on where your risks are at, your dependencies, start to identify areas for improvement. But the key to a digital twin is you're then able to test your hypotheses, test your changes in an environment that is safe, to see how those changes would impact real life before you implement them for real.
So Jess, you mentioned digital twins in fueling aircrafts, but is there any other applications that you can apply digital twins to?
Yeah, of course. So there's another example. We work with the MOD on Sellar, and that is a virtual representation of their estate of storage facilities and the associated operations and capabilities as well.
So a gorgeous private jet's just landed behind us. Earlier you mentioned Sellar, so what is Sellar?
So it's a digital twin we created with the MOD. They all had different systems at the different facilities, different operating procedures. And so it was quite difficult to understand where inefficiencies were, also the capacity and available capacity. So we helped them model out the different facilities and the characteristics of those facilities. So things like capacity, even things like temperature, so they could understand what kinds of things could be stored there. And we also mapped the different data sources from those facilities into that model so that it was one single source of truth. And that allowed different stakeholders at different locations or different facilities to be able to ask questions of the bigger picture. And then they could start to actually look for areas where they could optimise the use of those facilities. And it actually saved the MOD several millions of pounds, and it's still in use today.
And then looking into the future, how is Sellar going to contribute to that? And is there any particular digital twin or concept that is looking into the future?
So another good example of digital twins is one that we did with Defence Fuels Enterprise with the MOD. and that was a digital twin of one of their refueling stations. So that's a refueling tank there. One of the air stations that we worked with, they had several different storage facilities for fuel, big tanks, and also refueling vehicles as well. And they had different events that would happen through the year, and they had to try to understand what impact those upcoming events would have on their demand for fuel. And they were kind of struggling to predict that. And then they also wanted to be able to predict what changes they made structurally or to their operations, what that impact would have in the real world. So we came in and we modelled out all of the moving parts, the different assets like the vehicles, the tanks and their operations, and all of the different relationships between those moving parts. We built a data pipeline that took data from sensors on vehicles, in tanks, etc. And we also mapped data from other business systems as well to that model. And that allowed us to create a digital twin that would enable operators to put in details on the variables of an upcoming event and understand what demand they would have on fuel, and also what issues might arise that they could then mitigate ahead of time. And they were also able to predict future events as well. Start to ask questions about, if we change this part of the operation, how is it going to impact our efficiency?
So when it comes to refueling the aircrafts when they're coming in, could you give a bit more context around digital twins and the applications?
Yeah, of course. We saw a lot of aircrafts coming in and out today, and there's a lot of moving components. You've also got to understand what capacity your storage tanks are, what capacity your refueling.
And that was the monitor, wasn't it, on the side of the plane that we saw?
On the side of the refueling tank, yeah, exactly. So there are also sensors within those tanks to feed back to the business systems to show how much fuel is available and where fuel needs to be moved from and to. So the digital twin basically brings all of the sensor data together, but also it brings together other data, for example, the schedule of when those aircraft are coming in and when they're leaving. It helps them to then understand which runways need to be used for those different aircraft. Sensors can also be used to look out for hazards such as leakage. That's good for safety compliance. And also digital twins can be used to scenario test different changes to operations to see the impact. So if you've got a hypothesis that actually if I change my configuration of refueling vehicles, is that going to make my operations more efficient, or is it going to have a negative impact on something down the line? So I think in the future, companies, industries, businesses, defence, government agencies are all going to need to work together more. And we already see that, especially with defence. They work with industry partners and academia, etc., and also other governments. In order to do that, we need to bring lots of different types of data together into a single context. And I think digital twins really helps to do that. And I think we'll also see machine learning and AI being used a lot more heavily with digital twins.
So we've covered a lot of different areas of digital twins, obviously fueling, the application with MOD and defence, but where can people find out more about CACI's work in digital twin applications?
So we have a lot of use cases on our website, caci.co.uk, and also white papers and blogs that we've written around the application of digital twins and their benefits.
Digital twins was an area of emerging technologies that I wasn't necessarily familiar with prior to today. So Jess has explained that they can be as simple or as complex as needs being. They use applications like AI and machine learning, and it's really interesting hearing about the different applications as well in digital fuels and how it's used in MOD and in the defence sector. We really hope you've enjoyed the whole series, and if you haven't already, make sure to like, comment and subscribe on this one, and check out the rest of the series on our YouTube channel.